I'm introducing the physical world and measurement, just the concepts. Okay. Physical quantity. എന്താണ് ഫിസിക്കൽ ക്വാണ്ടിറ്റി എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഏതൊരു ക്വാണ്ടിറ്റി അല്ലെങ്കിൽ ഏതൊരു സബ്സ്റ്റൻസിനെയും നമുക്ക് മെഷർ ചെയ്യാൻ പറ്റും എന്നുണ്ടെങ്കിൽ നമ്മൾ അതിനെ വിളിക്കുന്നതാണ് ഫിസിക്കൽ ക്വാണ്ടിറ്റി. ദാറ്റ് ഇസ് എനി ക്വാണ്ടിറ്റി ദാറ്റ് ക്യാൻ ബി മെഷർഡ് ബൈ an instrument is called a physical quantity. For example, length, mass, electric current, temperature, speed, these all comes under physical quantity. And the physical quantity can be of two types, that is the fundamental quantity and the derived quantity. What do you mean by fundamental quantity? Fundamental quantity means it is a basic quantity or a base quantity. That is, it is an independent quantity. The fundamental quantities does not depend on other quantity. For example, length. Length is an independent quantity. Mass, temperature, electric current, these are all independent quantity. That is, it does not depend on any factor. That is, it is termed as a base quantity or a fundamental quantity. And the quantity that can be derived from or extracted from the fundamental quantity or a base quantity is called a derived quantity. That is, it is a dependent quantity. That is, derived quantity in the sense it depends on some fundamental quantities like length, mass, time, and all. For example, speed. Speed is a derived quantity. That is, it is derived from the basic fundamental quantity, that is distance, time. So speed is a ratio of distance by time, which is a derived quantity. Similarly, density. Density is also a derived quantity from the basic fundamental, that is mass and volume. So in general, fundamental quantity means a independent quantity and the derived quantity is a dependent quantity. Next is the unit. What do you mean by unit? Unit is the chosen reference standard of measurement in multiplies which are physical quantity expressed. For example, length of a road is 3 meter. That is, for a standard measurement is a meter. So a quantity which can be expressed in a standard measurements, it is known as a unit. Okay. Measurement of physical quantity is expressed by a number accompanied by a unit. Measurement of physical quantity is expressed by a number accompanied by a unit. That is, numerical value n into unit u. That is, 3 is the numerical value and m is the unit. So, length of a road will be, that is, physical quantity is the length, or the fundamental quantity is the length, and its measurement is represented by a numerical value which is 3 and the unit, that is meter. We have two quantities, that is fundamental and the derived. Similarly, the unit that is chosen for measuring the fundamental quantities are said to be the fundamental units. അതായത് ഫണ്ടമെന്റൽ ആയിട്ടുള്ള ക്വാണ്ടിറ്റീനെ നമ്മൾ മെഷർ ചെയ്ത് അത് റെപ്രസെന്റ് ചെയ്യാൻ വേണ്ടി ഉപയോഗിക്കുന്ന യൂണിറ്റ്സ് ആണ് ഫണ്ടമെന്റൽ യൂണിറ്റ്സ് എന്ന് പറയുന്നത്. അപ്പൊ തന്നെ നമുക്കറിയാം ഡിറൈവ്ഡ് യൂണിറ്റ് എന്താണെന്ന്. ഡിറൈവ്ഡ് യൂണിറ്റ് മീൻസ് the units of derived quantity or the units that can be expressed in terms of base unit are called derived units. For example, that is of a fundamental unit, the fundamental quantity is length. The unit of fundamental quantity length is meter. Similarly, for a mass, it is kilogram. Time, it is second. Now, what is a derived unit? Derived quantity, for an example, we can take as speed. Speed is a derived quantity which is derived from the basic fundamental, that is distance and time. Distance is meter and time is second. So, derived unit of a derived quantity, speed is equal to meter per second. In some cases, the units of derived quantity are named in honor of greatest scientist For example, unit of force, that is Newton. Unit of frequency is Hertz. Now, what do you mean by system of units? System of unit means a complete set of units for all kinds of physical quantity, which includes both fundamental and derived quantity. Actually, it is a system of units. That is, the units set of units completely enclosed for all kind of physical quantity. That is, it can be a derived or it can be a fundamental. Now, few common systems are CGS system or Gaussian system, FPS system, MKS system, and SI system. This is a table showing the physical quantity in CGS system, FPS system, and MKS system. The physical quantity length is represented by in CGS system is centimeter and symbolically it is cm. Whereas in FPS system it is foot, that is ft, and in MKS system it is meter, so symbolically it is m. Whereas in mass in CGS system it is represented as g, and in FPS system it is as pound, and in MKS system as in kilogram. For the time in CGS system, FPS system, and for the MKS system, time is represented as second. The next table shows the physical quantity represented, that is in International System of Unit or the SI unit. That is the physical quantity length in SI unit is meter. So it is represented as m. The second fundamental quantity, that is mass. Its name of unit is kilogram and symbolically it is kg. The third fundamental quantity is time, that is represented as in second and symbolically it is s. Whereas in electric current, the name of unit is ampere and symbolically it is capital A. Fifth one is the temperature. The name of unit is Kelvin and it's represented as capital K. Sixth is the amount of the substance. That is, the name of unit is mole, M-O-L-E, and symbolically it is mole, where M-O-L. Seventh one or the last fundamental quantity, that is luminous intensity, which is candela, that is CD. There are two supplementary quantity, that is the extra quantity in the SI system other than the 7 basic fundamental quantity, that is the plane angle and solid angle. Plane angle is represented by radian and the solid angle is represented by T radian, that is SR. What do you mean by dimensions of physical quantity? Dimensions of physical quantity mean physical quantity can be expressed in 7 fundamental units. And these 7 fundamental units comes as a dimension of physical world. That is, power to which base quantities are raised to represent the quantity. For example, acceleration. Acceleration actually is a derived unit or derived quantity. It is a ratio of velocity by time. So velocity's dimension divided by time dimension will give the dimensions of acceleration. Now, what is the dimension of velocity? So in general, velocity means length by time. So length is represented as L and time is represented as T. So length by time, that is L by T or L T raised to minus 1. So dimension of acceleration will be equal to velocity dimension by time dimension. So velocity dimension is L T raised to minus 1 and time dimension is T. So T is taken to the numerator part and L T raised to minus 2. So mass will be 0, that is m0 L raised to 1 e raised to minus 2. Hence, the dimension of acceleration are 0 in mass, 1 in length and minus 2 in time. Similarly, for the density, dimension of density is 1 in mass, minus 3 in length and 0 in time.